Welcome back. We're looking at a case 2 example of an arithmetic sequence. Now, not all sequences can be categorized into these three cases that I'm giving you: case 1, case 2, and case 3. But the majority of the patterns will be solved by using the three different cases. In other words, case 1, case 2, or case 3. Approximately 90% of sequences in series at grade 12 level. You may find that 10% may be a combination of the others, and then you're going to have to do some kind of manipulations. So don't think that this is the be all and end all of sequences in series, right? Okay, anyway, so case 2 is where we are given. What does a case 2 question look like? Well, case 2 questions are you're given the type of sequence is given, right? And also any two terms of the sequence is given. Any two terms of the sequence is given. Right, so that's what you have as given. The next thing to talk about is how do you solve these questions? Well, you are going to have to, you're given the type of sequence and any two terms, right? They need not be consecutive terms. And secondly, the types of questions you will get is you're going to have to determine the sequence, and then it becomes a case 1. And then you're going to get any case 1 questions. Because once you've got the sequence, it becomes a case 1. Okay, and you solve this by means of simultaneous equations. Now let's see, what do I mean by this? To solve, you're going to use simultaneous equations. Is that loading? It's not loading. Give it a moment. Solve using simultaneous equations. So let us look at our first example now. Okay, so an example of a case 2 question will say, in an arithmetic sequence, the first term, that one's a bit too easy. Let me think of something. Let's say in an arithmetic sequence T2, in other words, the second term is equal to 7, and T10 is equal to 31. Now this is what a case 2 question looks like. It's telling you the sequence is arithmetic, and it's giving you any two terms of the sequence. Now how do you solve this? Well, you have to solve it simultaneously, right? So I'm going to put there, solve simultaneously. And generally the thing that you need to do is you need to find the sequence. In order to find the sequence, you need to determine the following. Determine A, because it's arithmetic, the first term, and determine D. That's what you're looking for. You're looking for A and you're looking for D. And so let's find that. Well, I'm going to start over here and say, let's start with T10. T10. What does T10 look like? Well, do you agree that T10 is going to be A plus n minus 1 is 10 minus 1, so it becomes 9D, and that is equal to 31. Then we'll go to the lesser one and say that T2 I'll put over here, and I'll say T2 is equal to A plus 2 minus 1D. And simply put, 2 minus 1D just becomes D. And we say that T2 is equal to 7. And now we can apply simultaneous equations simply by saying, let us subtract the top. So I'm going to put that there, minus the top equation minus the bottom equation. And you can only subtract like terms. So A minus A gives me 0A, so I'm not going to put anything over there. And 9D minus 1D, negative times positive is negative, so 9D minus 1D gives me 8D. And if I put this in, I'm going to say 31 minus 7 is going to be 24. Right. And now we can easily solve for D. How do we solve for D? Well, I'm going to divide that side by 8, and I'm going to divide this side by 8. And therefore, d will equal to 3. Now I need to similarly solve for a. But now that once I've got d, I can take it back and I can say, well, take this d, put it into any of the two equations. And I'm going to say a plus d is equal to 7. We know d, so a plus 3 is equal to 7. So what plus 3 gives me 7? The answer is, of course, a must be equal to 4. Now once you've got that, you can easily determine the sequence. You know a is 4 and d is 3. And then I can say, well, if a is 4, d is 3, and the sequence is arithmetic, right? Then I'm going to say the sequence is 4. Add 3 to that, I'm going to get 7. Add 3 to that again, I'm going to get 10. Add 3 to that, I'm going to get 13. And any three terms, of course, that's sufficient to say that that is the sequence. Now the sequence is automatically given, and therefore from here on it becomes case 1. Becomes case 1 from here onwards. Okay, there we go. So that's a case 2 example. Very simple, and we're going to do a little bit more of that when we tackle the revision exercise.